Exercise 1017 in Chapter 10, Simulation Modeling, goes like this. Sean Bishop, a neuroscience PhD student at Clarksville University, has been having problems balancing his checkbook. His monthly income is derived from a graduate research assistantship. However, he also makes extra money in most months by tutoring undergraduates in their introductory neurobiology courses. His chances of various income levels are shown here. There's a table below. The assumption is that the income is received at the beginning of each month. Bishop has expenditures that vary from month to month. He estimates that they will follow the distribution provided below, and there's a distribution provided. Bishop begins his final year with $1,500 in his checking account. Simulate the cash flow for 12 months, then replicate your model 200 times to identify Bishop's ending balance at the end of the year and probability that he will have a negative balance in any month. You may want to pause the video at this point and copy the headings as I've laid out here for problem 1017 on page 464 in the text. The first thing we need to do is create the probability distributions for income and expense. We're provided with those numbers. We have income levels at 850, 900, 950, and $1,000. These are discrete distributions. There are no pennies. We have the probability of each level of income at 35%, 25%, 25%, and 15%. Note that these probabilities must add up to 1. We'll determine the lower range for each of the income levels and their probabilities. We'll begin with 0 as the lower. The upper will be the lower plus the probability of that level of income. The lower bound for the next level of income is equal to the upper bound of the previous level of income. The upper bound for this level is the lower bound plus the probability of this level of income. Once we have those two formulas for line 2, we can copy those down and see that we've calculated the lower bound for each level of income by bringing over the upper of the previous level, and we've calculated the new upper bound by adding the new lower bound to the probability of income at that level. Checks for us are the lower begins with 0, the upper is a 1. That means that we've used all possibilities. We'll repeat the process now for the expense distribution. We have 800, 900, 1,000, and 1,100. And the probabilities for each of these at 0.05, 0.2, 0.4, and 0.35. Again, we begin with our lower at 0, and the upper equals the lower plus the probability of expenses at that level. Our new lower is our previous upper. Again, the upper is the lower plus the probability at this level. Once we have the second row calculated, we can copy those down. We have our check figures 0 and 1. So we're in good shape. Now, we need to set up our monthly income. The problem asks us to create a model for 12 months. That's step 1. Step 2 then is to replicate that model 200 times. So we'll do step 1 first. We're going to set this up for 12 months. So I'll label the months from 1 to 12. We were given a beginning balance of $1,500 in the problem. So month 1 begins with $1,500. Now we need to determine our level of income. So we need to go to this distribution table. We're going to use the lookup function to go to the distribution table and find, based on a random number, the level of income for a given month. So we'll enter lookup. The value we want to look up is the number generated by our random number function. We want to look at that number, which is going to be a continuous variable between 0 and 1. We want to look for that in our lower distribution. We're going to set that to absolute. And when we find that value, we want to go ahead and get the corresponding level of income. We'll set that to absolute. Now, because we're using random numbers, my answers will not match your answers. So you need to make sure that you have entered the formula properly and then trust the results. We'll do the same thing for expense. We'll take the lookup, generate a random number between 0 and 1. We'll look that value up in our lower end of the expense distribution, make that absolute. When we find that value there, we will go and get the corresponding expense value and make that absolute. We're making ranges absolute by pressing the F4 key. And we're viewing our cells by pressing the F2 key. That allows us to view and edit what we've put into each cell. Now the ending balance is just a straightforward income expense calculation. We're going to take the money that we start the month with, our beginning balance, add to that any income that we derive during the month, and then subtract from that any expenses incurred during the month, and that gives us our ending balance. Our ending balance for month 1 becomes our beginning balance for month 2. Because we used absolute and relative cell references correctly, we can copy these down to month 2 and calculate at random our income, expense, and ending balance. Then I can select all of those and create my model for the 12-month period. Now that I have my model, I'm going to right justify these two cells. I'm going to get the ending balance. To do that, I'll just copy the ending balance for month 12 right here. That's the year-end ending balance. Then I want the probability of a negative balance. And to get that, I'm going to count the number of times an ending balance that is negative occurs in the ending balance column. Careful not to double count the final ending balance here. And divide that by the total opportunities for the balance to be negative, which is 12. Every month could have a negative balance. So I'll use the COUNTIF function, and I will look up to my ending balance range, stopping there. And if it is less than 0, I want to count it. Then I want to divide that by the number of opportunities, which is 12. That will give me the probability of a negative balance. I'm going to give that just a couple of decimal places. Now I've completed the model for a 12-month period for Sean Bishop's income and expense. Now what I want to do is replicate that model 200 times and calculate the average end balance and the probability of a negative balance after 200 replications. I'm going to use the data table function in Excel. I'm going to replicate this 200 times. To do this, there are several ways to create a column of numbers from 1 to 200, but in the run column, I have to indicate the number of replications. I want 200 replications, so I have to number 1 to 200. I'm going to place a number there, use the fill function. On the Home tab, all the way to the right, I have fill. I'm going to select a series. I want the series is a column. I want it to increase by 1 with each new row, and I want to stop at 200. Say OK, and it will create a column of numbers from 1 to 200. Then I want to get the ending balance and place it in the ending balance cell in my table, and I want to get the probability of a negative balance from my 1-year simulation and place that in the negative balance column. Now, I want to select this area. I'm going to do that by holding down the Shift key and selecting these 3 columns, and I've released the Shift key now. Now I want to do Control and Shift and down arrow, and that will select all of those columns. Now I'm going to go back up, just move over here and get the slider and slide it back up to the top so I can see my titles. As you can see, I've selected all of the runs 1 to 200, selected the ending balance column and the probability of a negative balance column. Now I want to go to my Data tab, do some what if analysis. I want to create a data table. The data table is columnar in nature. You can see that the input is across the columns. The run numbers are in the rows. So I place my cursor in the column input cell. Now I need to indicate a cell that's not going to be used in the model. Any cell will do. I usually put something that's just above my table that I'm not going to use and say, okay, Excel just needs that cell. Now Excel creates the data table that shows the ending balance and the probability of a negative balance for each run of my 1-year model. Now I can calculate the average ending balance by just taking the average of the ending balances. I can start here, hold down the Shift key, press the End key and the down arrow, then the right parenthesis, press Enter. That will give me my ending balance, the average ending balance after 200 replications. Then the probability of a negative balance, the same thing. I can see here that the range I'm dealing with is M4 to M203. So I can take the average of negative balances on the N column. So I'll take N4 to N203. And I get the probability of having a negative balance during any given month of about 2%, 1.96%.